This recording is for Primary Math 3, back in the Intensive Practice book to some challenging problems, pages 85 to 87. Now, when the book says challenging problems, some of them are going to be hard and some of them are going to be really easy, and it might be different for different people. So don't let it turn you off when it calls it a challenging problem. Attack it with confidence, though we're at least going to give it a good try. It starts off with a question we did similar in this week's assignment in the Challenging Word Problems book. For the numbers from 1 to 100, how many times does the digit 1 appear? And how many times does the digit 0 appear? Thinking about this in a logical way, the digit 1 occurs in the number 1 and 11, 21, and 31. We want to think in terms of an organized list. So if I think in terms of the ones place, in this line, I see that it happens 10 times. It occurs 10 times in the ones place. Once in the ones, this is the second, third, fourth. So 91 is the 10th occurrence of the digit 1 in a ones place. If I think about the digit 1 in the tens place, well, I have a 10, an 11, and a 12 all the way through the digit 19. And again, I'm not worried about the ones place, so I'm going to ignore the fact that there's a 1 in the 11, just like I ignored the tens digit 1 on this other one. And what I find is that there are 10 times that it happens in the tens place. But also don't forget that we have the hundreds place. And the only number, of course, that has a number in the hundreds place is the number 100, and it occurs, of course, in that number. And so the digit 1 appears 21 times. And that would be the answer to that first problem. Now, the second part of that problem asks about the digit 0. Well, a lot of digits are going to have a similar answer. 0 is actually quite different. 0 comes in all the tens, 10, 20, 30, all the way to 90. And if you count those and stop and realize there's only 9 of those. That only happens 9 times. Oh, but I forgot one, didn't I? I didn't go all the way up to 100. So that's the 10th one. It happens again in the 10 times. The number 0, or the digit 0, doesn't appear in the tens digit ever, except, not in a 2-digit number, but when you get to the number 100, that's the only time that the 0 occurs in a tens digit, because we don't say 03, 04, 05, we just have a 3, 4, 5. When the 0 is a leading digit, we ignore it. So 0 appears 11 times. I think your children work this problem twice in 1 week, just the way the schedule goes. Maybe they'll see it the first time and really have learned it by the time they see it the second time. Number 2, again, this is all about thinking. What is the smallest possible answer for the following subtraction problem? And they give us boxes, and we're going to subtract. And inside those boxes, we have to use the number 2, 5, 7, 9. And we want to use each number only once, of course. And I want my answer to be the smallest possible answer. Now, if I have the smallest possible answer, then what I want is the difference between them to be close. I don't want 97 minus 25. There's a long way from 97 to 25. What would you think would be some options for the numbers I could choose? If I want the numbers to be close together, and of course the biggest number has to be on top, I could do, let's just do some options over here. I could say, well, 92 and 75 would probably be pretty close. Some of it is going to be some guess and check. Do it and see what happens. What if we did 72 and 59? That looks pretty close. Now, if I did a number in the 50 and a number in the 20s, that's off by 30. Even if I made it as close as possible, I wouldn't expect this one to be the same, certainly because, again, this is the same number. Look how this is similar, right? But 50 minus 20 and 70 minus 50, this one definitely won't be the smallest. Now, I could also do, of course, 95 minus 72, but maybe it's pretty obvious that that this one's going to be a smaller number, because going from 5 to 2 is only a distance of 7. Anyway, hard to explain, easy to see once you see it, once you know it. So really the best thing to do is to come up with a few options and then do the subtraction and find out what you would get. Because the 9 and the 7 and the 7 and the 5 are both 2 away from each other, they're my best options for the first number. It will be smaller to have 92 minus 75. Think about a number line. 75 is here and 92 is here, or 72 is over here and 95 is up here. Obviously the distance between 75 and 92 is better than the distance between 72 and 95. If I'm going for the smallest, I want to go from the 75 to the 92 instead of the other way around. But again, the 59 to 72 might work too. So let's look at it. If I do this, I like to do it mentally. 75 to 80, think about how to get from 75 to 92. 75 to 80 is going to be up 5, and from 80 to 92 is 12 more, so this distance is 17. From 59 to 60 is 1, and 60 to 72 is 12. That distance is actually 13. And I think we've convinced us that this one's not going to be it, but just so we see it, it's 23. The smallest possible answer that we could get is the number 13, and that comes when you organize it 72 minus 59. By practicing and learning and struggling and doing a few problems like that, you will actually learn more than just seeing it done. So I hope you take a little bit of time to play around with those numbers and understand why some of them work better and are the answers. Number 3, in the following addition problem, if we add AB plus CD and we get 149, the question is, what is A plus B plus C plus D? Now that may look like a difficult problem, or maybe you look at it and think, well, gee, there's a whole lot of answers. Actually, there's a whole lot of answers for what these numbers are, but here's the thing I want you to notice. When you solve this problem, you actually add B plus D and get 9. And you add A plus C and get 14. So if A plus C is 14 and B plus D is 9, then you know that if you just add these all together, if you add everything together, you're going to get a sum of 23. So that would be the answer that you would box in and say. Now, there's a lot of things that you can add together to get this. For example, if you add 51 and 98, 51 and 98 do in fact add to be 149, and 1 plus 8 plus 5 plus 9, as we said, is equal to 23. You could play around with it. You can find a whole lot of combinations that add to be 149, but whatever they are, when you add the digits together, you get 23. Kind of an interesting fact. All right, I'm going to draw you a graph for this problem. It's a very interesting problem. The first thing you do when you see a problem like this is try to come up with some kind of an idea of what the limiting factors are. Of course, we have to have every number represented in every box, 1 through 9. Every digit has to be there and can only be there one time. Now, addition and subtraction, when I look at these, I think, boy, that's not very limiting. You can come up with a whole bunch of combinations in this group that add and subtract to each other. But one thing that's more of a limiting factor is when you get to this multiplication problem. Here's what I mean. If I put a 1 here, 1 times 2 is 2, that won't work because I can't have the same number in both of these places. And since every time I multiply by 1, I get the same digit, I know that 1 cannot be part of this last little equation. I could have 2 times 3 is 6. I could do 2 times 4 is 8. But if I go 2 times 5, I get 10, and 10 is not an option. So that is not a possibility. And matter of fact, if I use 3 times 4 and get 12, that's also not an option. So I could have a 3 or a 4, but I definitely can't have 3 times 4. So it's either 2 times 3 is 6 or 2 times 4 is 8. I definitely know that I'm going to use a 2 in one of these spots. Now, it doesn't matter if I put 2 times 4 or 4 times 2 or whatever. But what I also know is that this might be 3 and 6, or it might be 4 and 8. But those are the only options for the numbers that I can use for those two spots. And one of them is definitely 2. This front one is definitely a 2. So I can mark 2 off. It's not one of my possibles anymore. Since I have it down to 2 options, I made 2 lists on the right-hand side of the page. Both of them show me that 2 cannot be chosen. On the left-hand column, I have highlighted the 3 and the 6 to say, well, can I fill in these 6 dots if I don't use a 3 and a 6 or a 2? Or on the right-hand one, I highlighted the 4 and the 8 and said, well, can I fill in these other 3 blocks if I don't use a 4 or the 8 or the 2? And you could write up a list, and it would be kind of cumbersome, but you can kind of do it by looking at it and being systematic. Like, for example, I need to subtract one set and add one set. If I subtracted 9 minus 7, that'd be 2, so I can't do that. If I did 9 minus 6, that'd be 3, and that would work. But then I'd have to add the 1 and 5 and 7, and 1 and 5 don't make 7, so that's no good. What if I put the 9 and the 5 together? 9 minus 5 is 4. That doesn't work because I've already used the 4. And 9 minus 3 is 1. That doesn't work. Notice that I can't use 9 in the addition. I would have to have 9 be here, and 9 doesn't work there. Right? I mean, 9 can't be, I can't do 9 plus something. I have to do, and I can't do something minus 9. So the 9 would have to go there. I should have said that first, and I didn't. So what I've just done is show that this one doesn't work. I can't do 9. Let's see, I guess I didn't do, yeah, I did. I think I did this one. 9 minus 3 is 6, but 1 and 5 isn't 7. Yeah, I said that one. So this set of numbers is no good. But I can look at the same thing, and again, I have to have the 9 in front. What can I subtract with 9 and make this work? If I do 9 minus 8, 9 minus 8 is 1. Can I use 4 and 5 and 7 to make an addition statement? And it's no, I can't. And you know what I wasn't considering, actually? I did it on my notes, and then I thought I just figured something else new out. 9 could be there. So I need to think 9 is going to be one of these two places. So let me think about ways I can add up to 9. Let's go back to this other column and see, can I find 2 numbers that add up to 9? If I do, well, you know what? If they added up to 9, they also subtracted. 9 minus 6 was 3, so we have actually already tried that. That's the same thing said two different ways. Okay, so I'm not as out of it as I thought I was. Sometimes these kind of problems just take some clear-headed thinking. They're good puzzle problems. Maybe even as a family, sit down and work a puzzle some night, see what you can get out of it. Okay, so if I do, I did 9 minus 8. What if I do 9 minus 7? That gives me 2, and I don't have a 2 to use, so forget that one. If I do 9 minus 5, that gives me 4, and look what I have left for my other set of numbers, a 1 and a 7 and an 8. So I can use that. I can do 9 minus 5 is 4, and I can do 1 plus 7 is 8. Now notice, I could do, it doesn't matter how you write it, you could do 4 plus 5 is 9, and 8 minus 1 is 7. It still uses the same numbers. Okay. However you do it is fine, but just realizing that that there's a lot of different ways to write it, but you're going to always have these numbers connected. The 1 and 7 and 8 will be connected. The 9, 5, and 4 will be connected, and they can actually be connected in either of these groups. I could have 1, 7, 8 on top or 1, 7, 8 on bottom. But the two, we chose 3 and 6, so let me go back and fix that too. The 2, 3, and 6 definitely have to go here, but of course it doesn't matter if it's 3 times 2 or 2 times 3. Okay, so that's the kind of problem I like to call sit and soak. It doesn't always come out quite the way you mean to it, even when you say it out loud like this, but the point of it is to play around with the numbers and begin to see the patterns and to realize that there are only two options for the multiplication part, and that the 9 is going to have to either go in this spot or this spot. That's an important thing to realize and to begin helping you know how to think through the numbers. Okay, number 5 is a very old trick math question. We have 3 cats who are going to spend 3 minutes eating 3 fish. You'll find out about me real fast. I'm not very artistic at all. And it takes them 3 minutes to eat the fish. So then when you say, how long will it take 100 cats to eat a total of 100 fish at the same time? The temptation is to say 3 cats, 3 fish, 3 minutes, 100 cats, 100 fish, 100 minutes. But what you realize is if I just kept adding another cat and another fish, since they're all eating at the same time, the answer is that it will take 3 minutes for 100 cats to eat 100 fish at the same time. When you're reading a math problem, make sure you think about it and don't just take the obvious answer, because it can be tricky. Number 6, Dawn needs to travel from town A to C, and there's 4 routes that she can get there from town A to B. And then there's 5 routes to get from B to C. So I'm going to color code mine so we can talk about it. The question we're trying to find out is how many different routes can Dawn take from town A to town B? And the answer to that is if Dawn starts on that top route like this, and then she has 4 choices. Oh, I did it backwards. Hang on a second.